Let's start. Do the screen share. Get the thing. All right. So I know it's been a little bit since we talked about use case modeling because last lecture we had a quiz lecture, so we had to interrupt the use case modeling lecture. But it's okay. We'll just do a quick recap of what we've covered so far. Um, if you remember, so we all began with system context modeling. All right. And with system context modeling, the issue was we didn't actually know what the external entity was, and we're trying to figure it out, just like you did in the actual quiz. So with system context modeling, we're trying to figure out the who slash the what, because it doesn't have to be a person, it could be a thing. Now that we figured out the who and the what, we're trying to figure out with use case modeling. Okay, we're trying to figure out why. Okay, and when we do use case modeling and we're trying to answer the question of why, we start to zoom into that system in the middle and we start to create these use cases. These little bubbles on those use cases represent the actual services that are being offered to the system, uh, to that particular user, and the relationships that we have, it shows which use cases are offered to which users and external entities outside, and which external entities outside are we interacting with, the system is interacting with, while it's executing any particular one of these use cases. All right. Um, Now remember, we had the use case model. Okay. Now the box is a little bit bigger because we're looking inside. Okay. And just like with system context modeling, everything outside is considered an actor. An external entity is an actor. It always fits outside, nothing inside the box. And inside the box, only our use cases. So there's no such thing as a use case that's outside. There's no such thing as an actor that is inside. All right. And uh, in system context modeling, those actors outside, we draw them as a box because sort of a class diagram. But with use case modeling, we draw that as a stickman figure. Not a big deal. It's really the same exact concept. All right. Which I said before, not everybody's a fan of the stickman figure because a lot of the times the actor is not actually a human being. So having a stickman figure is rather misleading. But still, use case modeling actually as an official language, it offers you the ability to draw the actor as a box if you want to. You can even use an icon of whatever it is that you want to represent instead of the stickman figure. But if you scour the internet online, then you'll see most commonly it's actually used as a stickman figure to represent an actor. All right. And again, just like system context modeling, it's only what's inside that's going to turn into code. Okay. This rule doesn't change. Okay. Obviously, actors outside don't turn into codes. Okay. And again, just like with system context modeling, we only care about the direct relationships with the external entities. We don't care about external entities and what they're dealing with other external entities. Okay, so that we don't really care about. Okay, and similarly, we don't actually care about um, even if the actor was another actor that we're dealing with. All right, which is fine. We don't actually care about that these two actors are associated with each other. All right, and none of these actors obviously turn into code at the end. Okay, so we just care about the ones that we have direct relationship with. Okay, some of these actors we call them the primary actors, and other actors we call them secondary actors. Primary actors are ones that interact with us in order to retrieve some sort of a functionality. All right, they have a purpose, they have a goal that they want to achieve. Secondary actors are usually actors that we begin the interaction with in order to facilitate the service, not for the system. Okay, we never create systems to serve so that we can serve it, but it interacts with the second actor in order to facilitate a service that was actually required by um, the primary actor. All right. Now, when we look inside about those systems or the use cases, all right, we said before that a use case, the golden rule is about the size. Can somebody remind me for the size? Can somebody remind me what is the golden rule? How big it should be? All right. One use case, one service. All right. Yes, exactly. One use case, one service. Ideally, all right. We saw when we were talking about the include relationship in last lecture, how there's a time and place where that rule might be okay to violate in order to improve the reuse mechanisms and to reduce redundancies and improve our maintenance efforts. But in general, one use case is equal to one service. Okay, I know my handwriting is horrible, but I think you get the point of what I'm trying to write here. All right. Now, remind me again, if I have a system like this, we have a use case inside, an actor outside, what is the one type of relationship that can exist between an actor and a use case? Can somebody tell me? What is the one type of relationship that can exist between an actor outside and a use case inside? What's it called? Exactly. It's called association relationship. All right. Now, association doesn't mean data link. Association basically means, as the word says in English, that there's gonna be some involvement between the system and that actor when that particular use case is being executed. All right. Now, that actor could have been involved with a different use case. All right. That's a different story. Right. And when that use case is actually being executed, then the actor will be involved when that use case is being. So it's not for every use case that's being involved or executed, then every actor has to be involved. Okay. We point at the ones who do get involved using the association relationship. All right. And we said before that if I have an actor, sorry, yeah, an actor and a use case, right, and we have an arrow going like this, what does this arrow mean? Does that mean that data is flowing in this direction? Yeah, but I'm talking about the arrow this time. No, not input. Never think about input, okay? Association doesn't talk about inputs. Okay? No. No, include is a completely different relationship, yeah, Ryan. Okay? Exactly. It's the initiate. So, Muhammad Faid, you got it right. Okay? So that means that the actor in this relationship, the actor is the one that always initiates this relationship. Okay? So, in case this is make a call, all right, then this would be my caller. Okay? Opposite, if the arrow is pointing in the other direction, then that means that this association between the system and that actor is always going to be initiated by the system. And so a good actor in this situation for the make a phone call use case would be the callee. All right. In case we have a straight arrow without any arrows at the end, straight line, sorry, without any arrowheads at the end, that means it's a bidirectional association, right? Which means that either the actor or the system can begin that interaction. Okay. Now, One thing I want to allude to here is that when I'm writing that use case name, you notice that I always start with a verb. Okay, always a verb. Because a use case is something to do. All right. Now, a system context modeling, when we looked at the external entities outside, they're always a noun because it's a who or a what. They're not a thing to do. All right. And similarly, in the opposite, should never be a use case that has a name that actually is a noun. Okay, because use cases are not things; they are actions, functionalities. Okay. Now, between a use case and another use case, we said there's 4 types of relationships that exist. Okay. One pair is sort of like a pair of cousins, and the other pair is another pair of cousins. The first of which is called the include relationship, and the second is called the extend. Okay. And then we have the generalization, exactly. Generalization. I'm not sure if I got the spelling right. And we got implementation. Okay. And we like to think that these two are a pair of cousins. These two are another pair of cousins. Okay. And we'll talk about how they are cousins in a minute. But let's begin with the include. Remember, so the include is very much like the regular function code that we have in our regular procedural code. And then basically we have, this is the base use case, and then we have the dashed line like this, and then we have the inclusion use case, all right? And then we write the word include with angle bracket as such, okay? It's actually dashed, not dotted lines. My drawing abilities is not really the best. Let me just take another crack at this. Yeah, there we go. That looks much better. Okay. In other words, the way I'm reading it is that B includes I. Okay. This relationship, does it sometimes happen or does it always happen? Can somebody tell me? It always happens, okay? And this is why we like to signify it with the color red, because it always happens, okay? So B is always going to include I. Now, it might include I at the beginning of the functionality, it might be in the middle, might be at the bottom, might be multiple times. That's fine, okay? And because it's always, the reason why it's actually always is that B would be incomplete without I. Whereas I, on the other hand, doesn't really care about B, so I would be complete unless, طبعا, of course, it just so happens that I in itself is including something else. But let's just keep it simple for now. All right. So B would be incomplete with I. So again, a classical example for this, if B was the average function, right, and the inclusion use case is the sum function, you can never compute the average without computing the sum. So it's something that might happen, might not happen, right? On the other hand, when we looked at the extend relationship, okay, between two different use cases, okay, the arrow is pointing in that direction. And again, we put the angle bracket with the word extend. And notice this is the extension that is pointing to the base. So we say E extends the base. All right. Now what that means is that the base was actually complete, and the E was the one who is incomplete because it wouldn't make sense without extending the base. Okay. So a classic example of this, if this was a phone cover and this was the actual phone, okay, the phone would do just fine without the cover. The cover would be rather meaningless without the phone, okay? This relationship, does it always have to happen, or does it sometimes have to happen, sometimes not? Sometimes, exactly. And this is why we like to signify it with the color yellow, okay? Now, how do we know when to actually extend it and when not to extend it? Somebody tell me. How do we specify when it should happen? Because we already said it's not necessarily that we know exactly when it's going to happen, but it may happen, may not happen. But on what basis should I judge that this extension should happen? Okay, let me give you a hint. No. This is the type of relationship error handling that could be in here, but this is not what we're talking about right now. Okay, so how we know that we actually plug in the E inside the B. Yeah, exactly. We just write when you need to use it. Yeah, and we use it. We say that. Yeah, in the form of a condition. Yeah, exactly. Naif, you just got that right before I did. So we write down a condition. It's just like an if statement. Okay, so an if statement, right? That means this code over here may happen. So we may enter over here or we may skip it. How do we know? Well, we know by evaluating the condition that's in here. So that we know if we go this way or we're going to go that way. Okay, and because sometimes it's happening and sometimes it's not happening, that means that the extension E cannot be that vital to B. I mean, if it is, then we have to use the include relationship. All right. So the sort of information that I would put in extension usually would be either optional, that it may or may not happen. All right. Or we like to put in error handling. Now, if you think about it, this is the last thing that we signed off on in the last lecture. So we said at the end of the day that an if statement, okay, there's some sort of a condition, okay, there's some sort of a condition, right? So we're either going to branch in here or we're going to go outside. Just a moment. My echo.
Is that good?
So the mute, you gotta mute.
Yeah, I
microphone. All right. Now, this in the middle could have been optional stuff. Okay, or it could be error handling stuff where we may need it or may not need it. Okay, optional, it is pretty obvious what we're talking about when we say optional, because optional basically it's kind of like I have I'm buying a book and I'm giving away a t-shirt. I don't have to give away the t-shirt in order to buy the book, but nonetheless it's optional and I can just give it to add it to extend it to the original use case. Okay, and then maybe at a later point when the condition is not there, i.e. the promotion is not there, then I can just remove that extension altogether if I really want. Error handling is the same thing. At the end of the day, we're evaluating some sort of a condition, so some big error has happened. Okay, now in a use case model, in a use case description, it does have the text inside talking about what we call the nominal flow. I'm going to discuss this in a minute, and there might be some deviations as we're describing a use case. For example, like I want to get some sort of a piece of candy from a vending machine. All right, so we like to keep those deviations to the things, those slight deviations to the things that are sort of like related to the domain of that use case. Okay, so if this is like get some sort of a candy or get some sort of drink from a vending machine, then and it's expected that I would pay by cash, but the customer decided to pay by a credit card. That's still within the realm of that business of that use case executed. If somebody wanted to buy a Pepsi, but there's no Pepsi available, again, not a big deal. I mean, it's still within the realm of that use case executed, right? But if somebody's buying something from a vending machine, the vending machine catches fire, right? And then we need to call an ambulance, we need to call a fire truck. That's obviously a little bit extremely outside right, the realm and the business of what the use case is about, right? Actually, I don't want to be actually talking about anything about fire trucks in here when I'm talking about buying a Kit Kat. It doesn't really make sense, okay? It obscures the real purpose of having that use case in there to begin with. So I want to keep it outside. So I'm going to create a different use case outside, talk about all about fire truck handling and the ambulance stuff that I want to talk about over there. Yeah, that's when we're talking about the yeah. So that would then extend exactly. Yeah, you saw right. Yeah. So that would extend the original use case. All right. Now, normally, like I said, I'm gonna warn about something called functional decomposition, and I'm gonna visit this subject again because this is something that students and even practitioners tend to fall in quite a bit. Is that now we get breakdown happy, okay, and we start to create a whole bunch of includes, all right, and we start to misuse the include relationship and the extend relationship as well, okay. So we said with the include relationship, okay, if I am a base and I'm including an inclusion use case, but this inclusion use case over here is only included by that base, then there's no point in actually taking out this functionality outside of here, okay? Then might as well just shove it inside, okay? So I would actually put the B and the I in here and just remove that I altogether. So again, remember if I have an ATM machine, it offers one service. That one service would be to withdraw cash, okay? And normally I would have a pin validation or validate pin because I'm using a noun here, so that's the best. So validate pin, and obviously you would want to include, all right? But if that ATM is only offering that one service over here, then really this is the one thing I should be reading, okay? Why even am I visually even putting this on the diagram? It doesn't even make sense, all right? So I would have just normally take that validate pin and put it in here. Oops, that's a bit too much. Okay, so I'm going to talk about the value in here. Okay, now in a situation where that inclusion use case is actually being used by more than one, is included by more than one base, then in this case, it does justify the fact that I would take it out. Even if this on its own is not a full-blown use case on its own. So we might break the rule. It's okay to break the rule of the one use case, one full service. But again, this is because I don't want to take this text over here, this green text, and then copy it over here, copy it over there, copy it over here, copy it over there, right? And we said this is problematic because in case I want to change something about the validation this line, I have to go change it over here, change it over there, change it over here. If I miss one, then I have inconsistent documentation at this point. Another exception would be if I have my base over here is including a single inclusion use case, and that inclusion use case is only being included by that base use case, it would be okay still to have that inclusion use case outside if that inclusion use case outside in itself is offering a full service on its own, that on its own, it would be beneficial to an actor on its own. So a classical example of this would be to like the withdraw cash, and this is like check balance. Obviously, when you're withdrawing cash, you want to check the balance because you don't want to be withdrawing something more than what you already have. But sometimes you just want to check your balance without actually having to withdraw cash. Okay, so that would be another situation where it's okay to have an inclusion use case that is actually being included by one base use case only. Okay, now when it comes to the extend relationship, the warning signs is, remember what we said, we have the phone cover for the phone. Usually the phone cover is pretty specific to that phone, okay? That's actually the truth. If you buy a cover that's, you know, for a particular phone, iPhone 12, it is, I know that exists. It probably won't fit on any other device. Okay, even the sub model, it has to be that specific so that when you buy the cover, it has to be as such, right? Now, if I end up creating a generic cover and I say I'm going to use this for all my phones, chances are that cover is not really an extension, but rather a generic functionality that I'm trying to give away to all my other use cases, right? And again, we're falling down into functional decomposition again. It might be a good idea to flip it into an include in this case, but not an extend, okay? So think about it this way. If I created a generic phone cover and I start using all my phones, most likely it's not even going to fit any single phone. All right. So if I'm seeing this situation over here, this is my extension. Okay. And I'm seeing a whole bunch of bases and they're being extended by that one same use case, then it's one of those that I have to say, you know, am I doing something wrong over here? Okay. So like I said, just the fact that you've actually seen an inclusion use case that is being included by one base use case doesn't mean mathematically that functional decomposition has happened. It's just one of those cases, just, you know, take another look inside. And again, if you see an extended use case that is actually extending more than one base use case, then it doesn't mean that it's automatically a functional decomposition that is happening. All right. Just guys, give me just one moment. Okay, sorry guys, I'm back here again. All right, so that was it. The last thing that we've said was, you know, with the base, we say it's aware of the inclusion. It knows the details of the inclusion, so it knows where and when that this inclusion will be plugged into the base. Okay, but with the extension, it's the extension that's aware of the base. The base is not really aware of the extension. All right, so the base doesn't actually know exactly when the extension is gonna تفضل علينا and comes with the extension. The extension's got to figure this out, obviously through a condition, but knowing where it's gonna plug in its extension, it doesn't know. The base doesn't know. But what the base is gonna do is gonna open up a number of what we call extension points. Extension points, think about it this way, is like the USB port that's on the side of your laptop. Okay, your laptop would work just fine if you don't plug anything into your laptop. But if you do plug something, you actually think about it this way, you're extending your laptop with some more hardware. Could be a mouse, could be whatever it is that you extended it with. All right. And the extension point is saying, it's kind of like the laptop saying, if you want to extend me, don't plug things into the keyboard and don't plug things into the screen. You're just going to break the laptop. You can plug it into that USB drive, the USB port that's on the side. Now, the last thing that I'm going to talk about here, which is also applicable to the generalization and implementation relationship that we're going to be covering in a moment, that is the direction of the arrow. Okay, so I have two use cases over here. I'm not going to write what, okay, but the fact that the direction of the arrow is pointing in this direction over here, that means that A needs B. Okay, and think about it this way. If you need a friend, you're going to be going and pointing at that friend saying, I need you. But on the reverse, the vice versa is not opposite. It's not true. So the friend who doesn't need you is not going to be pointing at you. So who's pointing at you is who needs who. Okay, so think about it this way. In an include relationship, okay, it's the base that needs the inclusion use case, and in an extend relationship, it's the extend that needs the base. Okay, So that's it. That's a recap of what we've covered in the last lecture. Today, we're going to be talking about the other two relationships. And the first of which is going to be called the generalization relationship. And generalization relationship actually is the same exact concept as we had in SE 120 and SE 220, meaning that the parent is a general concept and the child is a more specific concept. Okay, with classes, that means the concept of the general class is more general, so vehicle, for example, whereas the bottom class, the child class, is more specific, so it'd be, for example, like a car. Okay, and the way we always say is that the sub is always a type of the parent, but the parent is not always that particular type of a sub. So in other words, we're saying that a car is always a vehicle, but a vehicle is not necessarily always a car. Okay, and how that works is, for me to just step out here for a second. Okay, so think of it this way: if this is my vehicle, okay, then this would be my car. Everything about the vehicle is included in the car. It's true about the car, but the reason why we say that not every car, so not every vehicle is a car, because whatever it is that is adding over here, right, is outside that circle. Okay, and then later on we can have vehicle, then maybe here we have truck. Okay, we have vehicle, then maybe over here we have motorcycle. All right, now with use cases, what we're basically saying here is that this is some sort of a general service, and in relation to that general service, the specific use case is a specific type of a service. And let's take a look at some examples about this. Okay. But actually, before we get that, so remember, just like in generalization that we did, inheritance that we do in SE 120, everything that we had in here gets inherited to the bottom over there. So we actually get 1, 2, 3. One thing we can do, okay, we take that 3, we do an override. We can say that 3 we're going to do a slightly little bit different, or we can do some adding of the steps that we've inherited from the general use case. Okay. So, for example, this could be a situation where I want to execute or use the generalization relationship, is that I have a parent use case that says buy tickets, whereas the sub use case saying buy on sale tickets. They're really the same functionality. They're from the same family of use cases, all right, of functionality, of services, should I say. But the bottom one is more specific because I'm buying on sale tickets. And maybe one of the things that I want to do when I'm selling on sale tickets, I want to limit the number of on sale tickets so nobody would actually just come in, buy the whole stadium, and then resell it again at a higher price. So I limit it in that sense. Okay. Now we're going to move on to the last reuse mechanism. Then I'm actually going to come back again and revisit generalization again to speak about the differences. But so the implementation relationship, one thing you'll notice, it actually uses the same notation that we had with the generalization relationship, which is an arrow with an open head at the top, triangular head at the top. Okay. Now with the implementation, the top use case is abstract. Extremely important that we write that. And what we do sometimes to denote that it's abstract is two ways. We either write the word abstract, brackets, brackets like that, or we take that font and we make it italic font. Okay. Now, I just happen to use Arial font when I'm doing the slide, so the italic is not really showing that much, but you can sort of like tell that it's slightly slanted in comparison to the bottom one. Okay. But this is really how we show. Now, the mechanisms are exactly the same thing that is happening with the generalization relationship, as in the abstract is going to define some steps, okay, and the generalization, sorry, the child use case it's going to inherit them. It might decide to override. It might decide to add to it. Okay. And again, you'll say, well, Allah, this is the same exact thing that we were just doing a moment ago. Now, the thing is, the difference is that because that upper use case called abstract, it's not a complete use case. It's not a use case that I could have executed on its own. That's the main difference between the generalization relationship and the implementation. But the fact that it's inheriting and everything over here, we took it over there, it's probably the reason why we're using the same exact line over here. As a matter of fact, even in UML, when you create a class diagram, inheritance and generalization is the exact same line. In fact, all right, if you have an abstract class, okay, and you're implementing it in, or you're sort of like completing it, fleshing it out in a subclass, okay, and this is class A, this is class B, we say class B, what's the keyword in Java? Extends, exactly. Right, I hope this is what you guys were saying in the, right, exactly, extends. Good job, right? Because that's what it is, okay? It's taking, oops, it's taking this and it's extending it. Yeah, let me just erase all of this. Okay, now in comparison, well, let's take an example of the implementation relationship. So we're going to talk about the comparison in a moment. So this could be a classical case of using the implementation relationship. So I have here, for example, an abstract use case. It's called, in generalization, the base class need not be abstract. Exactly, it's not abstract. Okay, it is absolutely not abstract. But for implementation, it has to be, yes, exactly. Yeah, amen. Am I still right? Amen. Okay. So this top one is abstract. Now, this over here is talking about a number of steps of what I would do to perform a transaction. Okay. Then all of this is going to be sucked into the bottom use case that flesh out exactly how to do it. So one way I can do it is by cash. Another way I can do it is by credit card. Okay. So this one over here goes 1, 2, 3, 4, 5, and then the credit card is like 6 and 7. All right. Here's 1, 2, 3, 4, 5, and with cash is like 8 and 9. I say 8 and 9 because it's different than the 6 and the 7. Okay. Now, if I just execute this at the top only, nothing has happened. Without the 6 and the 7 or the 8 and the 9, nothing has actually happened. Okay. At the same time, I see 1, 2, 3, 4, 5 is exactly the same between those two. I don't want to keep writing it over and over again. What I actually want to be doing is come over here, write the 6 and the 7 only, and come over here and write the 8 and the 9 only. And this way I save myself having to repeat the text over and over again. Same actually applies with the generalization relationship as well. And in such case, if I happen to need to change, say, step number 3 over here, then I don't have to do it, the changes all over the place for all the sub and children use case. Okay. Now, coming back to the word implementation. All right. Coming back to the word implementation. The word implement means is to provide a particular solution. All right. And so I'm seeing here, I have the parent use case, the abstract use case is called 6 and 7, right? It's called perform transaction. And the way I should be reading this diagram is I need to perform a transaction. So this is my goal. How I can perform the transaction? By credit card. I can perform the transaction by cash. Okay. But on its own, it's not something that I can do on its own. Now, if I compare this to, let's go back here a few slides, to this slide over here, had I not had the bottom part at all, it would have been just fine. I'm just buying regular tickets. Okay. And that's the main difference between the generalization and so they quite a bit close, they're cousins, okay? But the difference is that the parent use case in the generalization is relationship is something that I could do on its own without the base, okay? Whereas with the implementation, no, I need to implement it. You can read it this way: I need to implement it. I need to flesh it out. I need that 6 and the 7. I need the 8 and the 9. Otherwise, 1, 2, 3, 4, 5 by itself is not enough. And if you remember, let me just put it all together here for a moment. When we have in SE 120, this is what they teach you, huh? In SE 120, we have an abstract class. Okay, and we have if a class is not abstract, we call it concrete. Okay, that means basically not abstract. Okay, we can create an object of this type of class. We can create an object, many objects, as a matter of fact, if we want to. Okay, but they always tell us that you cannot create an object that is of type abstract, right? And the reason this is the case, is because it's not complete. I've created an incomplete object. All right. So why is it that we bother with abstract classes to begin with? Much like we have it in over here, because it does contain a lot of information that is shared amongst different classes. So if I have a class here called human, okay, which could be male or female, okay? It's a lot of things about being human that exist in male and female. Eyes, mouth, nose, hair, legs, arms, right? How to run, how to sit, how to sleep, exactly the same things. I don't have to write it again and again in the male and the female classes, okay? Even if you go a little bit further inside, okay? I got, with the male, I got the boy, and I got, for example, man. There's things that are specific about the man that is not exist, for example, a mustache or a beard, okay? So that's the reason why we use abstract classes. That's the reason why we use, all right? Now, imagine this way. Imagine if you have that situation over here. Okay, I have a class over here, and it's an abstract class. Okay, and then I implement it by another base class at the bottom. Okay, but this at the bottom over here is the only class that's implementing it. Then I can just make it in one class. I just take this over here, shove it back in there. All right. If what's in here is not going to be shared amongst a whole bunch of other classes, then what's the point in separating? Okay, I'm just making, now it might make sense with coding because we always want to keep modular and so on. Okay, but with use cases, I only break down when I have to. Okay, so if I have a use case and it's an abstract use case, same rule applies. Okay, and it's being implemented by just the one use case, then it's going back to functional decomposition again. I don't want to do this. Okay, might as well just take this, shove it in here. Okay, but unless what's in here is being used over and over and over again, then that would justify using the implementation relationship again. And again, it would actually justify, no, sorry. However, with the generalization, it's a little bit different. With the generalization, had I had this situation over here, i.e., there's no other use cases that are subchildren of that parent concrete use case, that still is okay. That's fine. Because the reason I created the parent is not to share. It has actually two purposes. It's to share. In this case, I'm not really using the sharing. But the other reason is because on its own, it's a full use case on its own. Okay. The only difference that, this is the general version of that service. This is the specific version of that service. All right.
The general is closer to the extension.
The general is closer to the what?
To extend.
No. Completely different. Okay. So extend and include pair of cousins, generalization, implementation, another pair of cousins. I'm gonna talk. We still haven't gotten to that. We still haven't gotten. Huh?
Complete or incomplete.
Both in the extend and the include, there was something that was incomplete. Okay. But if you notice in the generalization, nothing was incomplete.
Yeah.
Well, the sub is incomplete because it's gonna inherit. Okay, but it's a completely different pair of cousins implementation generally. And again, I'm gonna talk about this. We haven't gone to that just yet. Okay. So anyway, moving on. Okay. So they said the difference is that here the 1, 2, 3, I can inherit it. Okay. I can override if I want to, or I can add. So this is override. Okay, but the difference is that the parent use case on its own, I could have executed on its own just fine. On addition, obviously, to the specific use case. With the implementation, if I go back again over here, had I just tried to execute the abstract use case on its own, it would have not executed. All right. So matter of fact, if you see something like this, an actor that is associated with an abstract use case, that it's not implemented by at least one, give me at least one use case that implements it, then there's something wrong here. Because that actor is going to execute something that is incomplete. Okay. So that's kind of like another flag that something is off over here. All right. Now talking about the cousins again. So we said the include and the extend are one pair of cousins because they're adding two different types of use cases. Whereas the generalization implementation, they are fleshing out or adding two different use cases of the same family. So in other words, it's kind of like over here, I'm adding strawberry with, oops, with chocolate. And over here, I'm adding sugar-free strawberry with just regular strawberry. Okay, now that doesn't make sense much. So let me just step out here for a second, discard. Let's go back again to, where is it? The whiteboard. Type. So think about it this way. This is withdraw cash. Just zoom out here for a second. And this is validate pin. Okay. What sort of relationship should I have between those two? Guys at home, show me you're engaged. What sort of relationship should I have between those two? They include, exactly. Okay. And I'll just save you the trouble and say the include is going this way. Okay. Now, let me read this in a specific way. Okay. Cash withdrawal is something. It's an A. Validation of the pin is something completely different. With the reuse, I'm always adding two things together. But what I'm adding is the A plus the B together. I cannot say, think of it this way. I cannot say that validating pin is a specific type of cash withdrawal. Doesn't make sense. It's something completely different than cash withdrawal. Okay. I cannot say that validation of the pin is one solution, one implementation of how I can withdraw cash. No, it's not. It's facilitating the withdrawal of cash, but it's not a way to withdraw the cash. Okay. All right. Now, even let's do the extent. Cover and the phone. Okay, this is A, this is B. What's going to end up happening is I'm going to add the phone to the cover and the cover to the phone. Okay, But I cannot say that the cover is a specific type of a phone or the phone is a specific type of a cover. It doesn't make sense. I cannot say that one way I can do a phone is to use a cover, or one way I can do the cover is to do a phone. Again, doesn't make sense. Okay, so this is why we say that the include and the extend are sort of cousins for each other, because together they have the A plus the B type. Let's move on to the generalization implementation. So here at the generalization, I said buy tickets, and over here at the bottom is buy on sale tickets. Okay, and I have this over here. Okay, if this is A, and I hypothetically put this down as B, and then I end up reusing doing the A plus the B, think of it this way. In order for me to buy a ticket, I ended up buying two tickets. One time I bought a regular ticket, and one time I bought, okay, I'm not actually executing two things. I'm ever going to be executing either the A or the B. Okay, or if I really want to think about it this way, if this is my delta, okay, i.e. the difference, and for some reason this is not, oh, there we go. If this is my delta, okay, if I'm executing the one at the bottom, I'm executing A delta. Okay, if I'm executing the one at the top, I'm executing A only. But I'm never executing both at the same time, because that means I'm buying two tickets. All right. Now, similarly, when we looked at the perform transaction, and at the bottom over here, we said perform transaction by, say, credit card. All right. Again, think of it this way, right? If I just add the A plus B, it won't make sense, because really I'm just adding A minus to a B. Okay. I mean, even if it was not a minus, it seems like I'm doing two things. I'm not really doing two things. Okay. I'm adding A minus. Now, this does actually look a little bit closer to the include. All right. Where this was my base and this was my inclusion. All right. However, I'm again not actually, if this is my delta, I'm actually executing the A plus the A delta. All right. Because what I'm actually doing with the A delta is I'm taking all of the A, inheriting it first, then I'm adding to it. Okay. Matter of fact, I'm not actually adding the A. I was actually adding the delta itself. So I took the A minus. I took that A minus and I put it over here. It was A minus plus the delta gives me my implementation. Okay. And so with the generalization being A as in a full use case plus a delta, where then if I execute the child, I'm moving the A over here. It's the A plus the A delta. With the implementation, it's A minus plus a delta. And I'm taking that A minus and I'm putting it over here when I want to execute the child use case. But it's not like I'm executing an A plus something that is completely different. Okay, or even worse, an A minus plus something that is completely different. All right. All right. Let me go back over here. So guys at home, is this clear for everyone? Okay. So in an exam, you'll face the situation quite a bit, okay, because I'm going to get you these type of questions. You'll be given, say, two use cases. I'm going to ask you what sort of relationship that should exist, okay? Or maybe even an actor with a use case. And again, gonna ask you what sort of relationship should I have? And what I'm gonna actually do is gonna write down here on the side, sort of like a multiple choice. But it's actually 6 things. Okay. First of which is association. Here I'm gonna write include, extend, generalization, implementation, and then at the last one is actually nothing. So just to make sure that you know what you're actually doing. Okay. Now, if it's between, let me just take this over here. I don't have to repeat that part. How do I do this? Just a moment. There we go. This one? Yeah. Sorry about that. I'm just making sure I get the. Let me just move this over there. Okay. طبعا. What you should be employing maybe to help you out a process of elimination. Okay. So we have the 5 relationship. This is association. This is include. This is extend, generalization, and then implementation. Okay. If you get an actor and a use case, then automatically all of those are out. Easy. Okay. Okay. Now, if you get a use case and another use case, first thing you want to do is say, this is out. So we got one out. Okay. Now, when I try to look at this, I look at the two use case. Okay. Are they same flavor? And how do I kind of like get the sense if it's the same flavor? You'll see actually quite a bit of the text repeating. Okay, like buy tickets on sale, perform transaction by cash. Okay, if it's the same flavor, I want to go with these 2. Okay, if it's 2 different things completely together, then it's gonna be one of those 2. Okay, so I'm reading something, XYZ, same flavor. Then let me just chop those 2 out, and then I start to decide whether I should go generalization and implementation. And then how do I decide if it's generalization and implementation? Look at the top one. Can I do it on its own? In other words, I look at the bottom one and I scribble it and I say, can I do the top one on its own? If the answer is yes, then I pick. Okay, if the answer is no, then I pick implementation. All right. All right. Now, if I'm reading things that sounds like the completely different flavor, okay? This is AB, another one is talking about CD. And I'm gonna end up adding AB to CD. Now it's the question of, here I'm gonna have the AB, all right? And he's got the CD over here. Who needs who, okay? Or, even better, this thing that's gonna happen between them. Is it always? Well, is it maybe? In other words, sometimes yes, sometimes no. If it's a maybe, then I choose extend. If it's an always, I choose and include. Okay. All right. And so back over here. All right. Now I'm going to focus on something that's called redundant associations. Okay. In a situation like this one, I have the general use case and I have a bottom use case at the bottom. It's inheriting everything that's from the general use case. I could reach the bottom use case through the parent. All right. So the bottom line over here, this one, this one over here is redundant. I didn't really have to do it. Okay, just to be clear about this, because you're indirectly getting it through. Exactly. Again, for redundant associations, if I have an association with the base use case that's being extended by an extension use case over here, this actor is getting that extension, obviously, when it does happen. Okay, not every time, when it does happen. I don't need to do this over here, an association that is directly with the extension, unless just so happens to be that what is in the extension is on its own a full-blown use case that I would be interested in doing by itself. And again, be wary, am I really falling into functional decomposition here or not? Okay. So unless I want to be doing it by itself without the base use case, then I don't really need to have that line go into the extension use case. Okay. Similarly, when I'm doing the base use case, I'm getting the inclusion use case. Matter of fact, I'm getting it always, because the include is always happening. Okay. I don't need to do a line directly from the actor to the base, to the inclusion use case, unless again there is a reason I can see that the inclusion use case on its own is a full-blown use case on its own that I could be interested in executing on its own without executing the base use case. Again, like we said, the withdraw cash and the checking of the balance. I might be interested to check the balance without having to withdraw any cash. Okay. Next up, we're going to talk about the actor generalizations. All right. We might, just for the purpose of understanding our users, identify that some sort of a relationship exists between users. Now, we have to be careful about this, okay? Because a lot of times the mistake that we do when we're doing this type of relationship is we're not comparing with the proper way of what the generalization relationship means, which by the way is exactly the same thing as in a use case or between classes, as in the bottom actor is a specific type of the upper actor. What we end up doing is we're using hierarchy that exists in a company, and we're assuming that whoever's at the higher level of the hierarchy, it goes up. For example, if I have a manager and I have an employee, which one of those two actors should be the manager and which one should be the employee? So which one should be the manager? Should be the top one or the bottom one? Okay, so again, that you fell exactly into the mistake that I was just trying to say here. Okay. No, Yasara, it's not the top one. Okay. Now, obviously, the answer is pretty obvious that it's got to be the bottom one. Okay. Now, a manager is a specific type of an employee. Okay. In other words, all managers are employees, but not necessarily all employees are managers. Again, if we go back to vehicle and car, we say that all cars are vehicles, but not all vehicles are cars. Okay. When I have a use case that is as such, all right, that means that this use case can only be executed if you're at the level of the manager. Okay. If you are specific enough to be a manager. However, not every employee can execute it. So you got to be careful about this. If I have this situation over here, use case A, all right, any actor that is an employee, in this case, the manager, can execute use case A. So I don't actually have to say that the manager executes use case A. Okay, unless the way the manager executes use case A is actually different than the way the employee executes a use case A. In this case, I want to actually have something here that is different. And maybe even likely, I could have had this situation over here. All right. This tends to be something that is, rather advanced, that rarely that you're ever going to come across this, however. Okay. Now, when I move on to the descriptions of the use case. So we said before that, that every use case, really the heart and soul of it is some sort of a textual description, okay? And that textual description tells us when to start, who we're interacting with, what data is needed, what is the normal sequence of actions, okay? Now, the normal sequence of actions is sometimes called the basic flow, okay? Sometimes it's called nominal flow, and in very informal sense, sometimes it's called the happy case scenario. I'm going to explain that why in a moment. Okay, and then we describe any alternative or exceptional flows. So exceptional when I have something that is really, really off, but if it's really, really exception, then maybe I should take that description and take it out into an extension use case. Okay, or if it's a slight deviation that I can keep it, it's a judgment call. It's not math. You have to be the one that decides upon this. Okay, now the way we write our document is as such. We write down, we have a basic flow, and then we go 1, 2, 3, 4, 5, and so on. And then we have alternative flows. And alternative flows is deviations from the basic flow and say, well, like at step number 3, if some condition happens, then do 5, 6, 7, right? And then I have to say return to where exactly. Okay, now let me step out over here for a second. Let me just discard this. Going back to the not this one. So think of it this way. Okay, so here I am. I got my use case description. I got my basic flow. And think of a use case. Okay, let me just draw a big use case as such. As there is a starting point, and I'm trying to do the following steps. Oops. Until I reach the end. And from the start to the end, when I reach the end, some sort of a service is delivered. This over here is what I call my it's what I call my basic flow. And this is what normally I expect to happen, say 90% of the time. Okay? This is the main scenario that keeps repeating over and over again. The reason sometimes we call it the happy case scenario is because nobody would ever approach a system and try to work with it in order hoping that it actually fails. Okay, we're always approaching a system in order to do some sort of a service, and we're hoping that it actually succeeds. Okay, you never stand in front of an ATM machine and say, I hope there's no money inside that ATM machine. Okay, you never stand in front of a KitKat machine and say, I hope, or a vending machine and say, I hope there's no KitKat. Actually, what you really wanted was KitKat. Okay, so you're trying to go through that middle line over here, trying to get from the top to the bottom, route number 1, so that you get the goal that you wanted. And this is what we expect to happen 90% of the time. Okay, now when we are trying to execute this line in the middle, sometimes we have deviation. Okay, this deviation is we call an alternative flow, AF. Okay, and you'll notice one thing. First, it's deviating from a point from the basic flow. Why? Because we actually started at the basic flow. Okay, and then if it does happen that we go through the alternative flow, we maybe execute a number of steps in the middle before we return back again to the basic flow. Because why we're returning back? Because we're trying to get back to maybe having some sort of a success. Okay, maybe sometimes this is not the case. Sometimes I hit an alternative flow and I decide I want to loop back. Okay, do this or do that, or maybe do nothing, just go back again. Sometimes I hit an alternative flow and I decide, wallahi, there's no good way, there's no two good ways about this, and I'm out. Okay, you wanted a Kit Kat, there's no Kit Kat. I don't want anything else. I just wanted the Kit Kat. So bye bye, I'm leaving. So we didn't actually end up with some sort of a service being delivered. We finished the execution, but without actually something actually happen. Okay, a failed use case, so to speak. Okay, now again, all alternative flows, there is some sort of a condition that I have to evaluate in order to know why. Okay, and if you think about it, this was the same thing that we were talking about when we talked about the extension use case. Okay, and there was some sort of a condition that I evaluate. So theoretically, they're actually the same idea, except for this over here is something that I would use to put down something that is a bit way off. Okay, air handling, that sort of thing. All right. Whereas if it's a slight deviation, okay, if it's a slight deviation like this over here, or that, or this one over here, and again, it's not something that is outside of this world. It's something that is within the realm of what this use case happening. Yeah, okay, you wanted the Kit Kat, you didn't find a Kit Kat, you wanted to pay by cash instead of a credit card. It's within the business. Okay, then this is where a good place that I would use an alternative flow instead. Going back again to the slides over here. All right, so let's take a look at an example. Oh. So this is a buying a ticket booking use case. Okay, so I'm not going to read the details, but as you can see, it's basically you have a basic flow, go 1, 2, 3, 4, 5, 6, 7. You notice that there is an alternative flow, says A1, we label A1, another one we label it A2, and we actually say the condition, why is it that, and when is that we actually want to branch off. So this, in particular case, I want to branch off to A1 in case I do not find available flights. Okay, so I'm just gonna skip here. So when I have no available flights, this is what I do. I do 1, 2, 3, and in 3 I say go back to the primary flow. Again, another name for basic flow. Go back to step number 2. So I couldn't find a flight. Go back and repeat again. All right. Another thing that we show in the description is the places I'm gonna have my extension points. Okay, remember the extension points is the places where the extension use case is going to come in with its extension behavior and starts to add it to me. So I say over here, I'm going to have my extension point, okay, that the credit card system is not accessible for some reason. So it's a little bit off of the situation. All right. And then this is what you do in case the credit card system is not accessible. So I'm going to have a use case outside, an extension use case outside. This is where it comes in and plugs in that extension behavior in that area where I have the extension point E. It's like the vending machine situation, all right? Right? And if you notice, the extension point, it doesn't actually have a description. It's like a USB. It's saying, all right, once you're ready to add something to me, this is where you add it. Okay, so extension point comes in, extension use case comes in with steps 1, 2, 3. This would be the place to add the 1 and the 2 and the 3. All right. This is a template that I do encourage you to use. You can actually copy paste that. Okay, so you'll have a name, must be a verb. Okay, the actors that are involved. Tends to, you get a brief description. This is an executive, like one-liner. Customer can withdraw cash from the ATM machine. Okay, we talk about the dependencies. I include use case X. I am extended by use case, or I'm extending, sorry. I'm extending use case. So this is a situation, it's a very rare situation where a use case is actually including something and it's also extending something else. Obviously, this normally won't be the case. Now, you'll notice use cases that include it's not here because I'm not aware of it. The sum should not be aware of the average. Okay. And also, the use cases that are extending it that is not aware of it either. It's gonna leave some extension points, but it's not aware of it, okay? So it's not gonna say I'm extended by the extension use case, all right? Preconditions and post conditions, gonna describe that in a moment, but here we got the normal flow, basic flow, alternative flow, same thing. Okay, then you got the basic flow, you got the extension points. Preconditions, this is a state of a system that needs to be true in order to go ahead and execute that use case. This tends to trip students a little bit, okay? Now, you need to be, say, logged in. That's the state that you're in. So that's the precondition in order for me to execute withdraw cash. In case, this is the way it's supposed to be. In case it's not there, then I can go ahead and include the use case, what's it called? Validate pin, okay? Now, in reality, you're gonna say, like, you didn't allow me to get in. How can I go and validate the pin? All right. And tends to be in the reef world, what you're actually doing is you're validating the pin first, then you're choosing that I want to withdraw cash. Okay. But regardless of the details over here, now the whole point is that a precondition is different than saying go ahead and do something first. It's, is this situation true? Okay, I'll go with it. If it's not, then I can't. Okay, but it makes sense that if it's not true, then in this case maybe go ahead and execute something else first before you come, and then come back to me. All right. Same thing with post condition. Now post conditions means I'm going to be doing some stuff, but before I leave the use case, I need to make sure that the state of the system is in a safe situation. All right. For example, I'm going to withdraw some cash from the ATM machine. All right. You know, I want to make sure that the new balance is equal to the old balance minus the cash that was withdrawn. If for some reason that calculation doesn't add up, then I want to maybe do a rollback, revert, stop, and leave the use case while not executing anything. Okay. Or keep working at it until you fix it. Figure out why is it that the new balance is not equal to the old balance minus the withdrawn cash. Okay, so that would be a post condition. At the very bottom over here, you'll see something called other requirements. This is where you want to specify any non-function requirements, because remember we said that use cases only talk about function requirements. In case you have a non-function requirement that you want to keep an eye out on while you're executing that particular use case, say, for example, I want to execute that use case, but I want it done in less than 5 seconds. This is one of those non-functional things, because you're never going to write at any point system dot do it in less than 5 seconds. Okay, but nonetheless, I want to do this whole thing in less than 5 seconds. I want to make sure that this is made known to my designer, made known to my programmers. This is the place that I put it. Okay, because that less than 5 second, it's not applicable to the entire system. It's just when I'm doing that one use case. So this is where I associate it with the description of that one particular use case. And with that, we're done with use case modeling. Next lecture, we'll be doing the in-class exercises. Extremely important that you come to those exercises. Okay, we'll begin again with easy, and then we'll pick up the complexity. All right. Guys, do you have any questions at home? Guys, over here, Nora, Aisa. Okay, so I'll see you on Wednesday, inshallah. I'll see you on Wednesday. Yeah, just.
Do you know when